Okay, hello everybody. I made a statistic refresher PowerPoint for you guys just to kind of refresh your statistics brain and get the stats juices flowing. I'm also going to post this on YouTube, and I will really try and not forget you guys when I'm famous. So, let's get this going. Okay, so today we are going to dive in with inferential versus descriptive statistics. So inferential statistics is when you infer and predict from data. So the first example is when you are estimating parameters. So an example would be, according to this data, I can see that the mean will probably be 88 in my study. So you're inferring from other data what your data is going to be or might be. And then with hypothesis testing, this is where you can use sample data to answer research questions. So you can see if 88% of your sample population perform better when they don't use phones after 10 p.m., you can infer that this is what would happen to the whole population. And then descriptive statistics is when you just describe data. So a descriptive statistics are parameters, so mean, median, mode, and standard deviation, and also graphs and tables, so things that you can visually see and just describing data black and white in front of you. So descriptive statistics are more black and white, and inferential is more in the gray area and more abstract. Okay, now we're going to talk about variability. Variability, it's also called spread or dispersion, refers to how spread out a set of data is. And so there are four factors within variability, and that is range, interquartile range, variance, and standard deviation. So we all know what range is. Range is the difference between the lowest and highest values. And then there's interquartile range, which is the difference between the values in each quartile. So if I have 100 values, there are 4 quartiles within that. I mean, there are 4 quartiles within any set. But let's say, for example, I have 100 values. So the first quartile would be 1 to 25, second 26 to 50, and so on. And then there's variance. Variance measures how far a set of numbers is spread out from their average value. And then fourth, there's standard deviation. Standard deviation tells you how tightly your data is clustered around the mean, or the average. A small standard deviation indicates that your data is tightly clustered, and you also have a taller bell curve. A larger standard deviation tells you that your data is more spread out, and you have a flatter bell curve. Okay, so the first statistical test we're going to dive into is independent samples t-tests. So this is the most basic statistical test in science. So this compares the means of 2 groups. So it's typically the control group and the experimental group. So an example of an independent samples t-test would be who performs better on a test, the group that drinks Coke or the group that drinks Pepsi. So the variable is what they drink, and then the 2 categories is going to be Pepsi drinkers versus Coke drinkers, and then it's between subjects, so there's 2 different groups. It's not both groups drink both Pepsi and Coke, it's one group Pepsi, one group Coke. And then the dependent variables in independent samples t-tests are always interval or normal. Okay, and then for paired samples t-tests, this is pretty much the same as independent samples t-tests, except that it is within subjects. So you're comparing the means of one group. So for this example, it would be one day you give one group Pepsi, and then they take a test, you see how they perform. And then the next day, on the same exact group, you give them Coke, give them a test, see how they perform. So it's the same exact as independent sample t-tests, it's just within subjects and comparing the means of one group. And the dependent variables for paired sample t-tests is the same as independent samples with interval and normal. Okay, so one-way ANOVAs. These are pretty much like t-tests, same dependent variables, interval, nominal. independent variable is categorical, dependent variable is continuous. The only difference is that this has 3 or more levels. And it's between subjects, just like the independent samples t-test. And so an example for this one is, what type of soda influences test scores? So you can have 4 different groups of people, and one group drinks Pepsi, one group drinks root beer, one group Dr. Pepper, and one group Coke. And that is the difference between t-tests and ANOVAs, just having 3+ levels. Okay, so on the previous slide when we were talking about one-way ANOVAs. So one-way ANOVA and an independent samples t-test are the exact same thing, except a one-way ANOVA is 3+ levels. And so with a paired samples t-test and the slide we're on now, a repeated measures ANOVA, it's the exact same thing, except 3+ levels. So independent samples t-test and one-way ANOVA is between subjects, while paired samples t-test and a repeated measures ANOVA is within subjects. So like in the last slide we talked about with a one-way ANOVA, different groups drink different sodas, and then they take a test, and then you see the results to see if different sodas have different effects on test scores. So with a repeated measures ANOVA, it's within subjects. So it would be the same group drinking the same soda to see the results. So it would be the same group drinking Dr. Pepper, take a test, get the results. Root beer, take a test, get the results. So it's the same group. Okay, so now we're going to move on to linear regressions. First, we're going to start with a simple linear regression. This studies the relationship between 2 continuous variables. So there's not necessarily an independent variable or a dependent variable, it's just 2 variables and seeing the relationship of them on a line. So this shows you the correlation, which then gives you the correlation coefficient, which is R. And R ranges from -1 to 1. So -1 is a strong negative correlation. +1 is a strong positive correlation. So negative and positive has nothing to do with the strength of the relationship, it only has to do with the direction of the relationship. Okay, so next in the linear regressions we're going to look at multiple linear regressions. So this is different from a simple linear regression because, you guessed it, it has multiple predictor variables and one outcome variable. This also shows you the correlation, and it gives you the correlation coefficient as well, same with the simple linear regression. So an example of this would be, does GPA, GRE scores, and IQ predict if you're going to get into graduate school? And so you need to solidify that there are multiple predictor variables and one outcome variable. It can't be multiple outcome variables and one predictor variable. I ran into this dilemma with my thesis because I wanted to see if frontal alpha asymmetry could predict mental health, stress, and emotional intelligence. And so I couldn't do that because I only had one predictor variable and multiple outcome variables. So what I have to do is just do a lot of simple linear regression. So keep in mind that a multiple linear regression, although it is multiple, there is only one outcome variable. Okay, so now we're going to talk about chi-square tests. So this looks at the relationship between categorical variables, and this can be between or within subjects, and both the independent variable and the dependent variable can have one or more categories. So chi-square can see whether a dataset fits a particular distribution, whether the distributions of 2 populations are the same, whether 2 events might be independent, and whether there is a different variability than expected within a population. So an example of a chi-square test would be if education level and marital status are related in the United States, because they're both categorical. And that was it. Thank you everyone for watching. I hope you learned something today. And if you have any questions, feel free to shoot me an email or comment below.